Welcome to the Explainer. Today, we're going to take something super simple, a potato, and use it to unpack one of the most basic, most powerful forces of life. Seriously, it's happening all around us and inside us, right this second, and it all starts with a little kitchen mystery.
You've seen this, right? You're making a salad, you sprinkle a little salt on a cucumber, and a few minutes later, there's a little puddle of water. Where in the world did that come from? It's not magic, it's biology. And it's the exact same reason a crisp lettuce leaf can go totally limp.
So, the secret to our kitchen mystery is all about how water moves on a microscopic level. And we're not just going to talk about it, we're going to see it in action with our own eyes, using that potato. The whole thing is driven by a process called osmosis. And the rule is actually pretty simple. Water always tries to find balance. It moves from an area where it's pretty pure or less concentrated to an area where there's a lot of stuff, like salt, dissolved in it. It does this by passing through a special barrier, a semi-permeable membrane. Think of it like a club's bouncer that only lets water molecules through but tells bigger molecules like salt, nope, you're not on the list. This means a cell's environment is absolutely everything. If a cell is sitting in what we call a hypotonic solution, that just means the water outside is cleaner, with less stuff dissolved in it. But if it's in a hypertonic solution, that means the water outside is really concentrated, like super salty. And believe me, that difference makes all the difference. Okay, so based on that one rule, we can guess what's going to happen. Here's our prediction. If we put a potato cell into a low-salt hypotonic solution, water should rush into the cell, making it get all stiff and firm. We call that turgid. But if we put it in a high-salt hypertonic solution, water should rush out, causing the cell to shrink up and go limp. That's called plasmolysis. And if it's a perfectly balanced or isotonic solution, well, then nothing much should happen at all. All right, enough with the theory. It's time to get our hands dirty. Or, well, at least a little starchy. Let's set up the experiment and see if we're right.
Our setup couldn't be simpler, really. We just need 3 of everything. We'll take 3 potato slices, cut them all the same, and then we'll test them in 3 very, very different solutions.
So, what are these 3 solutions? For our hypertonic test, we're using pure distilled water, 0 salt. For the hypertonic test, we're going to the other extreme, a really concentrated 10% salt solution. And for our control group, we've got an isotonic solution with 0.9% salt, which is meant to be pretty close to the natural saltiness that's already inside the potato's cells. And the procedure is as easy as it sounds. We cut the potato slices, we dunk one into each of our labeled solutions, and then we just wait. We're going to give it about an hour for that invisible force of osmosis to do its thing. Okay, time is up. The experiment is done. So, what happened? Did our predictions hold up? Let's take a look at the results, because they are pretty dramatic. All right, first up, let's have a look at the potato slice that was chilling in the pure distilled water, our hypotonic solution. And would you look at that? It's exactly what we thought would happen. The slice feels super firm, it's rigid, maybe even a little heavier. It soaked up water like a sponge, making all its cells swell up and get turgid. The change is totally obvious. Okay, now for the complete opposite. What about the slice we left in that really, really salty water, the hypertonic solution? Whoa, it's like a totally different potato. This slice is limp, it's soft. You can bend it easily. It's actually shrunken and looks kind of wrinkled. That is a massive physical change, and it was all caused by the silent, steady movement of water. So let's just lay it all out. In the pure water, the potato got stiff. In the super salty water, it got soft and floppy. And our control slice, the one in the isotonic solution, just like we predicted, not much changed at all. It's a perfect visual. The fate of the cell is completely dictated by the water around it. Okay, so we've seen what happened. Now for the big question, why? This is that aha moment where everything clicks into place and it all comes back to osmosis. So here's the deal. Potato cells aren't just empty bags of water. They're full of their own salts, sugars, and starches. So when you compare them to the pure water in the glass, the inside of the potato is actually the more concentrated place.
Osmosis says water has to flow from the glass into the potato cells to try and even things out. That rush of water creates pressure, and that's what made the slice so firm. But in the salty beaker, the rules were completely flipped. The water in the beaker was way saltier, way more concentrated than the inside of the potato. So water did what it had to do. It rushed out of the potato cells and into the beaker. This huge exit of water basically deflated the cells, making them lose their structure. And that's why we ended up with a soft, wrinkly slice.
So, okay, a potato in salt water gets floppy. Big deal, right? Well, yeah, it is a big deal, because this simple little experiment shows us a rule that governs life itself, way, way beyond a science lab.
You might be asking, how does this apply to my life? Well, the answer is it's happening everywhere, all the time. It's critical for food, for medicine, for pretty much all of nature.
Just think about it for a second. Ever cured meat with salt? That's just osmosis. You're pulling water out of the cells so bacteria can't grow. Why do medical IV drips have to be isotonic? Because if a doctor gave you pure water in an IV, your blood cells would swell up and literally burst. It's how giant redwood trees pull water up from their roots. It's the same exact thing. And that brings us right back to where we started, our kitchen mystery. That puddle of water you see when you salt a cucumber? That's the cucumber's own water being pulled out by osmosis, the same way water was pulled out of our potato. Mystery solved. It all boils down to one single, incredibly powerful rule. Water follows the solutes. Or, to put it simply, water goes where the party is. If you get that, you get one of the fundamental engines of biology. So, with just a plain old potato slice, we've watched a universal law of life play out right in front of us. It really gets you thinking, doesn't it? Now that you understand this fundamental dance between water and salt, what other mysteries about how life works, from your own body to the entire planet, can you start to figure out?